Welcome to Examrace. We will see the important topics we need to cover for the CSIR Physical Science exam. So we will see some important topics for the CSIR NET. It is you must have to learn. You must have to remember those topics, related questions, topic related formulas, and all these things for before going to the exam. So when we talk about the mathematical physics, see mathematical physics, then classical mechanics, then your electrodynamics. Okay, electrodynamics. And if we talk about quantum mechanics, okay, and most probably you can say thermodynamics. Okay, thermal physics. So why I'm talking about these topics, basically mathematical physics is of 30 to 35 marks every year. Same way, if you go to the classical mechanics, it's almost 30 every year. Electrodynamics almost 30, 35. I'm just taking average. It may be vary, but it is near about 30, 35. Okay, quantum mechanics almost 35. And if you see the thermodynamics, is thermodynamics in which statical physics is also there, is also about 30 marks. So if you average this, 1, 2, 3, 4, 5, 150. Okay, 150 marks questions are from this only, these topics only. Okay, because we have lot of options in part B and part C. That's why due to the option, the question are of 75, but we have to attempt only 55 questions. So we have lot of options, but we have to work smart. So for this, if you see the mathematical physics, important 30-35 marks, and in this few topics are most favorite for the favorable for the CSIR, and these topics are, if you see in this slide, the most important thing is your this differential equation, and in the differential equation the important thing is this linear order differential equations, first and second order. This is the important part for the mathematical physics. Okay, then we see this one. If you see the integral part, okay, integral part of solutions, particular solution functions, some questions are asked in this. Recently the CSIR is focusing on the interconnecting topics. Okay, if you see the paper, the topics are interconnected, not asked from the particular topic. Means a question from directly from the one topic is not asked, it is asked interconnectedly, from one topic is interconnected to the other. Example, the question last year question, means the 2023 question, if you see the one question was there, and in that atomic physics was interconnected with the thermal physics, and both the atomic physics and the thermal physics concepts are applied, then you able to solve the problem. That's why eye on each and every topic is most important, but few topics are there that you cannot skip those topics. Okay, next is, you can just remember what are the Hermite series, Bessel function, all these things. So important is the Bessel, Legendre, these are the most important, and Hermite, these are the most important functions that are asked. So you have to remember, the last year 2023 also the Bessel function was asked. That's why you have to remember this. Then your Fourier series, the question from Fourier series is asked alternative years. Okay, Laplace transformation, integral from Laplace transformation is asked every year. Okay, if you see last year question, that was e to the power minus x into x sine x dx, and the limit was from 0 to infinity. This type of question is a integral question, but it can be solved by using the Laplace. So you must have to uh, learn this topic, Laplace transformation. Okay, so the topic related to the Laplace, whether it's the inverse or whatever, you have to focus on the Laplace transformation. transformation, so that you can easily solve this type of questions. Clear? Next is, if you see this Cauchy's integral. Cauchy's integral is the one of the most famous questions are asked in the every year. You can see the most famous questions of Cauchy integrals are asked. So you have to just see the how to solve the Cauchy integral, what are the concept related to the Cauchy integrals. Okay, especially when we talk about the poles. Okay, poles are important. Okay, poles are important. Integration related to the poles, these are the most important thing. Integration that for related with the poles, this topic is most important topic. Then when we come to the random walk problem, random variables and random walk problem are very much famous problems that are asked in the CSIR. So in last year, that is 2023, if you see in 2023, uh, instead of, if you see the random walk problem, it was 1D random walk problem, and in which one person is moving. Now they upgraded this type of question, they upgrade this type of question to 1D and two persons are moving. So they upgrade this type of problems. So you have to focus on random walk problem also. This random walk problem was asked in the exam for 5 marks. Okay, so focus on random walk problem. Now one question is from the Poisson binomial or normal distribution, either from this asked. Last year also, June 2023, this problem was asked from the normal distribution. Now in this, if you see, the most probably partial differentiation is important. Okay, then your trapezoidal Simpson rule, these are the easiest one. You can just look at this, because June 2023, if you observe the paper, a problem related to the bisection method is asked. Okay, bisection method. So all this bisection method is you see in the interpolation. So this is why the topic related to the interpolation, your trapezoidal and Simpson is important. Okay, so also this computational techniques for the root of equation is important here. Clear? Now, if you see the paper, you will see some graphical questions related to the classical mechanics, and in the graphical questions are related to the this phase space dynamics. The phase space dynamics is important here. Now, another one is if you see the basic thing, that is the stability problems and your center force. This is most important. Every year question is asked. Central force problem is most important problem. Okay, so this center force motion is important topic. Then your scattering 5 marks question asked every year. This year also, June 2023, scattering problem was there. Okay, so if you solve this scattering problem, then the problem related to the your we can say the this one stationary orbits problem, this is also important here. Okay, so if you remember the central force problem, the most important thing is the B effective. The B effective is what you have to remember, is a BR plus half of L square upon MR square. Okay, MR square. This is the effective potential that we know. Then in center force problem itself, you remember the polar equation. Polar equation is also important here. Polar equation of motion, that is 1 by R, because this question is also asked, is 1 plus E cos theta, because in problem what they ask the eccentricity. Now how you will find the eccentricity? You will have to reduce the equation in this format, then you will compare them and find the eccentricity. Now you know what is L here, isn't it? It's J square upon M MV, you can say. Then your most famous equation of motion under central force, if you remember, central force, and that is the most important, is your d2u over d theta square plus u must be equals to minus 1 upon h cut square f upon m u square. So this is what you have to remember. Okay, now if you see this in this the important topic is the Lagrangian and Hamiltonian. How to convert Lagrangian to Hamiltonian, Hamiltonian to Lagrangian, all this you have to remember. So because every year Lagrangian to Hamiltonian or either Hamiltonian to Lagrangian question is asked. This year also they ask the question, okay, Hamiltonian is given, they want to find the Lagrangian equation, isn't it? So double pendulum problem, especially the problem that is related to the Lagrangian is important here. Okay, so Lagrangian, your cyclic coordinates. Okay, especially when we talk about the important problem is that is related to your conservation laws. Okay, so this is the important thing that you have to focus. Generalized momentum, generalized velocity. They are generalized coordinates are very important here. Okay, and last to last year, you also see the variational principle problems, especially the calculus of variations. Okay, so Euler-Lagrange equation, the most famous equation. Without this, you cannot solve the path of the particles. So this is the basic thing that you have to know. Then this year also the question related to periodic motion is asked, that is in the matrix format, because this is the important thing, this is the important part of the classical mechanics. This is very very important. Every year I alternative slightly, if I average of, if I take the average of 10 year, in the 10 year almost 7 times the question related to the periodic motion is asked, 7 to 8 times. So this is very very important. Every year the question is related to the periodic motion is there. This year also, if you remember the problem that was having a spring that is attached to block, then another spring that is attached to block, then they are demanding some frequency ratio, angular frequency ratio. That's why this question is important. Okay, then your question related to the special theory of relativity. Every year 5 marks question, 5 marks question is fixed from this. Okay, 5 marks question is fixed from this. Whether the special theory relativity, whether it's related to the transformation of velocity, where important thing is the energy relation, your momentum relation. These all are the important things. Then canonical transformation. Canonical transformation is very important. This year 5 marks question asked June 2023. If you remember, x was given in term as a capital X and small p to the capital P was given. So you have to find the relation between something alpha beta was there. Okay, so this is also important. In the electrodynamics, the problems are related to the electrodynamics are interconnected with the other part of physics also. Okay, so you have to keep eye on each and every topic, especially when we talk about the electrodynamic induction. Induction is the most famous topic. Then your Maxwell equation in a free space, then your pointing vector. Pointing theorem problem is asked in this year also. 5 marks. Last year also this was asked. Okay, then we come to your scalar and vector potential. This is important thing. Scalar vector potential and gauge invariance. These two things are important. Okay. Now the problem related to the your dielectric and conductors is the most important. They ask the most of the problems related to the your dielectrics and conductors. Also from your Fresnel law. Fresnel law is also important. Then this is the topic that is also related to your optics as well as your electrodynamics. So that's why this is very important. Diffraction is very very important here, because the questions are asked in every year. The problem related to the diffraction is asked every year. Okay, then your important is, this is also important. This helps to understand the concept of the radiation. So that's why this is important, to understand the basic thing. If the basic questions or the some kind of question asked, you can deal with that easily. Clear? So this is the important thing. Then the important thing is here about the dispersion mediums, especially the group velocity, phase velocity, when we talk about the plasma. Okay. Now in quantum mechanics, the Schrodinger equation is very important, because the Schrodinger equation is the base of the quantum mechanics. That's why. But this is not asked directly. You know the Schrodinger equation, you know the concept related to the Schrodinger equation, then you move to the each and every part of the quantum mechanics, especially infinite square well. Infinite square well, finite square well, these all these are important because they are attached with some other problems also. For example, if I want to find the expectation value of any particle in a box, infinite box, then you must know how to deal with the infinite square potential, okay, to find the expectation value. Okay, and if we talk about the probability related to the particle in the infinite square well, then you know the eigenvalue problem related to the infinite square well. So infinite square well, finite square well, these are the basic thing that is important here, especially this harmonic oscillator. This is the important. Okay, then your tunneling through barrier has a certain kind of problem, or the problem that is related to directly formula. So you have to remember formulas and their importance, how to use these. Then especially the part angular momentum, orbital angular momentum, then your central again this center potential is spin. Okay, these all are the important parts here, especially if you see this hydrogen atom is very important, because graph related to the hydrogen atom, formulas related to the hydrogen atom is also asked. So I already told you the whatever the topic related to the hydrogen atom is important in itself. Then your perturbation, variational method, time dependent perturbation, time independent perturbation. You cannot skip this at any cost. You cannot skip this just by doing the concept related to the perturbation, variational method, and these three topics will give you 5 5 to 10 marks, even 15 marks if the questions are asked, because perturbation, every year perturbation question is fixed. Okay, especially they are they are demanding this degeneracy in quantum mechanics, and that degeneracy related to any kind, any topic, means they can relate to the time dependent, they can relate to a time independent. So degeneracy is important here with this variational method, your time independent, time dependent perturbation theory. Clear? Now this WKB approximation is also important. WKB approximation, then spin orbit interaction. This is a small topic, clear your concept. Okay, then we come to the partial waves. These are just 5 marks topics, that's why they are important. This is also phase shift. This one, if you see the Born approximation, this is the direct formula based questions. Just understand this, and if you remember the formula, if you remember their how to deal with the problems, you can easily solve this. So these are the important, because these are the advanced quantum mechanics, so it is very important. They are asked every time. If they are asked, they will ask in 5 marks, isn't it? Then we move to the electronics. Electronics is also asked. Electronics asks 15 to 20 marks, 20 marks. Okay, so in this circuits are asked, important thing. Okay, circuit Hall effect question this year also asked. This was a 5 marks question. Okay, your PN junction diode, this one. Okay, then your Jenner is important here. Jenner becomes important. Okay, then if we see the digital techniques. Okay, and if you remember from this, you can focus mostly on BJT, your transistors. These are the important here. Okay, so you must focus on what is the basic thing of MOSFET. Okay, this is also important, but you must focus on the Hall effect. Hall effect is the most important part here. Now if we see this, in this you can see, as I already told you, stability factors and these BJTs are the important part, because the circuit asks and problem related to this BJT is asked in the exam. Clear? So this is the important thing here. These are the important thing. Load line, your BJT. Okay. Also this one, the current again, ICO, IBO, BJT. These all are the important things. Now FET amplifiers. Okay, especially when we talk about the drain system, drain and source, this is asked in the exam. So FET is asked in the exam. Feedback amplifier is also important. Then your RC oscillator, this is the important, because from this the problem become either complicated, or if you know this you can easily solve this and get the 5 marks. Okay, so the problem is related to these RC oscillator is important. Then you obviously know the whatever the topic related to the op-amp is important, because op-amp is the pet question for the CSIR. They will ask you in each and every exam, in each and every 6 months they will ask. Means no paper can be there where op-amp question is not asked. So in op-amp, what you will see, you will focus on differential, integrator, integrator, non-inverting, inverting. All these things are important. Okay, important here. Then if you see the digital number system, this is the easy, and the question is asked from this also. Clear? Then your log op-amp, this is also important. Subtractor, integrator, all these are important. Now if we see the next, that is the, if you see in this, you will see that D2A, okay, D2A, then your A2D, D2A, these are the important things. These are the small thing, basic thing, you must know this. It's just not time taking, it's just a simple thing. You can just give 5-10 minutes to this, you can easily cover this, and if the question related to D2A, A2D, you will easily solve this. Okay, so this is important thing. Then your logic gates, logic gates are the basic thing, that is you must know this. If you are reading physics, you must know this, and you are able to solve the question related to the logic gate, question related to the number system and their conversion, because this is the important part that you have to cover. If you see this year of paper, you will see that lock-in detector was asked. It was 5 marks, and that was interrelated with the Hall effect also. So it's okay if you see. Then your curve fitting is easy, and you can easily score marks in this. Okay. Then your error analysis also easy. Okay, so you can look at this also. Then we come to the important thing about the atomic physics. So atomic physics, you must know this: LS coupling, JJ coupling. Okay, this is very important. Questions are easy. You can solve this. You can if you understand this, you can easily solve these two topics, LS and JJ coupling. Okay, then your problem related to your chemical shift was also asked in the previous year question. Larmor precession is important here. Okay, then your Zeeman effect and Paschen-Weck effect is also important, but this is, you can cover to understand the atomic physics more deeply. Then must thing is here that you must have to cover LS and JJ coupling. Okay, that how LS and JJ couplings are interrelated. This year, June 2023, your LS, the question related to the LS coupling and JJ coupling was interconnected with the thermodynamics. Okay, and they asked to find the probability. Then in this, the bond approximation is important. You can see this. This is the 5 marks topic. Then this important thing is in solid state physics, Bravais lattice. Bravais lattice is the important one. Okay, so whatever the Bravais lattice and these 4 topics are important. If you cover this, you can easily handle the question related to this. And every year solid state, most probably, if 3 questions are asked, 3 to 4 questions are asked, then at least one question is from the Bravais lattice or the reciprocal lattice is there. Especially FCC is more focused. Clear? Then if you see this one, in this the important thing is your nuclear charge density, your radioactivities, these are the important. And if you see the solid state physics, then free electron, this is important. Then Drude model is important here. Okay, the diffraction and X-ray, Bragg's law is very important. Every year question is asked, Bragg's law is important here. You must follow the concept related to the Bragg's law. And in nuclear, the most important thing, you cannot skip these things. Okay, the quark model. Okay, and your fundamental forces of nature, that is mass, spin conservation, mass conservation, parity. All these things are very important. Question is asked, 5 marks. So this is important because 15 marks, 10 to 15 marks question is from the nuclear physics. So from this, they most importantly focus on the fundamental forces, and that is the fundamental forces of nature, that is the mass, charge, and spin parity. This is important. Then quark model is important here. Relativity and relative kinematics is important. Okay, then the basic thing that you already know, just go through it. Okay, then is conductivity. Sometimes the type 1 type 2 superconductors question related to this 5 marks was asked. Okay, so the important thing is, when we see the nuclear physics, you must cover these two topics so that you can deal with the problem. Okay, then you can see this shell model also. Shell model and liquid drop model, especially the liquid drop model, is very important. Liquid drop model. So the question related to the liquid drop model, and you can also cover in this radioactivity. Radioactivity cover in the same thing. Okay, so you can see this is very important.